Hello everybody, I'm going to quickly go through this arrays practice and classes practice assignment. This is for the AP Computer Science class, and if you want to try your hand at it, you're welcome to, but this is due tomorrow, so at midnight. So this is just a little bit of a session to give you the basic idea of what you're supposed to be doing. To start out, I've emptied out my arrays practice file. And the first goal is to store all odd numbers from start to end in an array, given that a user is providing that start and end. So to start out, I am creating a scanner that will allow me to take input. Additionally, I'm going to have, my Java doc, etc., etc., etc. And have your purpose in there as well. Okay, so to start out, we have input, and I'm going to take just a start and an end value. And I'm not going to check them at all, just basic stuff. And certainly I can have something like this, where I say, that, and then end. There we go. And so now I've taken in my start and end values, and I can actually create an array. So here I'm going to make an array. It'll be an int array, and it'll be called odds. And odd numbers turn out to be, just to be safe, what I'm going to end up doing is end minus start plus 1. And that ensures that I have enough space if I split the array. If I start with an odd, I end with an odd, things like that. So that'll give me enough space. And I'm only going to be storing odd numbers, and I'm going to have no empty spaces in this array. Or at least perhaps until the end. So let's have a look at how I might store odd numbers. So I'll use a for loop. Less than end, and we'll start at start. And we'll say, we'll add 2 to each time. No, we'll do this. So if I%2 is equal to 1, if I have a remainder of 1, well, I want to store in odds position I divided by 2, the value of I. Why I divided by 2? Well, that ensures that I'll fill up every single space. Now, I could print out in this area, but I'm gonna practice printing out in a separate area down here. So this will do the actual storage. And this will do it'll print the array out. So for int I equals 0, I is less than odds.length, I plus plus. And then I'll print out odds I. And I'll print that like so with in array notation. If I plus 1 equals Oz.length, then I'll add a, if does not equal Oz.length, I'll add a comma. And then at the start, I'll print out brace, and at the end, I'll print out the opposite brace. Okay, so this is just some standard array notation from 1 to 20. And I see I have too many values. Oh, n minus start divided by 2. That's what I wanted. Technically, I could also do a math.ceiling on that. Start 1 to 20. Okay, and that prints out all of those. And again, I managed to do a print line when I did not intend to. Let's run again. 1 to 21. And it'll print out all of that. And again, there we go. And again, let's try 2 to 20. And it'll print out the first value. Why is that? Because we divided by 2. We stored in position 1. Okay. So there's a little bug there. You can figure out how to fix it. It has to do with up here, this part right here. So for 3, because I start a little late. So in this case, maybe I want to do I minus start. Let's see how that works out. Okay. So this plus 1 again gives us a little bit of play. So we'll just instead use a math.ceiling. Okay, and that there we go. Okay, so it looks ugly. You could do this above on a separate line, but that should give us a fix to our issue. There we go. Yep. So that guarantees that we always have the right size array, and this guarantees that we're always starting from the start. And you can try to figure out why this is. I mean, it sort of makes sense. First, if we're giving arbitrary start and end values, what ends up happening is, well, if I'm indexing my array, or if I'm going to try to go into an index of my array, a position on my array, from that start value, well, that start value may be later on, it may not exist. For instance, if I had put in 200 to 400, or 200 comma 201, that would give me a bit of an issue. So I have to consider first that the total range of numbers is going to be my end minus my start. I'll divide that by 2 to get all of the odds, for example. And then I'll take a ceiling on that in case I have a certain range. The other aspect of this is right here, where let's say I'm at position 200 to start. I want to subtract 200 to be able to store in my array position 0. So array position matters a lot. We don't want to overshoot our array. So this would be the canonical solution for storing odd numbers. For even numbers, I just have to do that. That's the only difference. For Fibonacci numbers, I would just change this condition. I just say if or for, let's say prime, if is prime, I, and then you have some prime function that determines if something is prime. And you can look that up, or you can see if we've done that before. But basically, it works very similarly to projects we've done in the past. And you could even do if is. I mean, you could generate Fibonacci numbers much more straightforwardly. You could just say, you could just have a Fibonacci algorithm and store in positions I. And then all of those, the primes and the Fibonacci's, you want to have to change this this value. And for things that aren't known, you might have to overwrite your array. So for instance, if you go beyond the bounds, you might do some check like this. I'm going to delete this for right now. You might have some check that goes, oh, if I, my current position or my current number or whatever it is equal to odds.length. Well, what do I do? What do I do if, say, my value, say, if my current value exceeds my length, well, I have to make a new array. So what I might say is that, maybe I'll double the size of my array. Maybe I'll say, int array temp equals odds dot length equals new int array times 2. And then I might say in here temp equals, I might have some for loop for int temp or int I equals 0, I is less than odds dot length, I plus plus. And then I might say something like this. Temp equals temp I equals odds I. And maybe I'd say at the bottom, odds equals temp. And then we'd have some situation where now odds is now a new array that's doubled in size. I store all the old values in a temporary array, I save that temporary array to my old array, and then I move on. Then maybe I'd save cur value. So that's sort of how you'd expand an array. And this is something that you'd be doing a lot. And if you're doing this a lot, then you want to use something called an array list, which we haven't yet talked about. Okay, so this is our first piece. And I'm going to move into the next piece in just a moment. It has to do with the student class. So if I look here, you should develop a class called student. The following is the UML diagram. And you test your student class out in a separate file, include javadoc for all methods, and have a javadoc comment at the top of each file. So let's make this. So I'm going to save this. This is sort of pseudocodey right now, but it's certainly something that should get you into a good position on that project. Next, let's make a new class student, and this will be pretty quick. Okay, so first I have political news. Okay, I have three different things. I have name, grade, and scores. So string name, int grade, and int array scores. Notice the minus, so it's private. Okay, so I have a private int array scores. And here I'll do something like the following. Okay, I'll make my constructor. And my constructor will have, no, it's not abstract. Okay, my constructor will have the following. A string n, an int g, and an int num scores. And what we'll do is we'll say name equals n, grade equals g, num scores, scores equals new int array num scores. And the whole purpose of that is to just initialize our variables so we can know how many scores we have and do things with them. Our next, I might as well do this. Okay, so our next thing that we're doing is we're going to use int grade, int get grade. So public int get grade. And this should be relatively simple, return grade. Okay, nothing special about that. And then we'll do int or string get name. Again, nothing special about that. And I'll do some javadoc comments on this. So it returns the student grade. Okay, so that means like grade 12, grade 11. Okay, example 12. This okay. So because grade has several different connotations. And then down here we'll have another one. We'll return the student's name. Okay, pretty straightforward. Now we want to do something a little more complicated. We want to add a score. So, well, seems like it'd be straightforward. It'll be void, and then we'll call it add score. And we'll add some sort of int score. Well, a straightforward way to do that would be to say, okay, well, scores, oh, I don't know an index. So I'd have to say score equals score. Well, what index can I use? Well, it seems like I might want to use some sort of global variable, some additional global variable, maybe current index. and we'll say it's an int current index, and we'll just initialize it to 0. And then down here we'll say current index, and every time we add a score, current index plus plus. Okay, that's all well and good. So seems pretty straightforward. Technically, I'd probably have to do something like this. If cur index is equal to, or greater than or equal to scores dot length, then let's say less than scores dot length. Then we'll do this. But then, otherwise I could throw some exception, but I'm not going to do that here. And this should almost always be true. But we just want to guard against that condition just to be safe. And then I want to say, okay, well, this adds a score to my score list, to a student's score list, and the score to be added. Okay, so that's pretty straightforward. The next thing I might consider is how to remove a score, how to get the number of scores, how to get the average, and a toString method. So here, let's say public void. The only one I'm going to do right now is, I could always do get num scores. Technically, that is not a void, that is an int. And we could do two things. I could return scores.length, or I could return cur index, because that would also be a representation of how many scores I've actually stored to this point. But maybe I'll have that be something different. Also, my public string toString would be very nice to have. And here I might say return string s equals that. And then we'll say s plus equals maybe name plus and then maybe a carriage return. And then maybe I'll say grade. Then maybe I'll do something like this, where I have a for loop. Maybe I'll print out all the scores. And here what I'll say is, you can always do the comma trick that I did in the earlier in the video here, but I might say scores position I plus a comma. And obviously this will add a comma to all of them, even the last one. You can always use an if statement to cancel that out. And then I might say s plus equals break n. Okay, and then plus get average, which I haven't written yet, and then I'd return s. And for get average, I might do something like this. Maybe double. So something like int total equals 0 for that. So this assumes that I'll call this when all the scores are printed, or when all the scores are entered. So I might say like that, and then at the end I'd say return. Or I might even do score total or cur index, just to ensure that it gives me the average of all the scores that have been entered up to this point. And even then I might do that here to ensure that just to ensure I'm not adding extra zeros or printing out things I don't care about. So let's try this out. And I haven't written my remove position, but you guys can try to figure that one out. So I'll call this student test. I'll have main method. And here I'll say student S1 equals new student. And they'll be called Merlin, grade 123. And I'll give him 3 scores. So maybe I'll say s1.add_score 5, s1.add_score 3, and then maybe I'll say maybe I'll print it. And it'll give me the proper average, even though it prints out that last piece. So we can always edit this so that it doesn't do that. Actually, I'll do that right now. It is this. So there we go. It'll print out only the ones I've entered. And if I were to add another score, maybe 12, well, it'll give me the average of that as well. Although the average of 5, 3, and 12 is not 6 because I have not taken into account that this should be a double. And that will fix everything for me. Okay, so you can easily see that this, well, you can't easily see yet. This would be actually pretty nifty if I were, say, a lazy teacher. Maybe instead of having one student, I'll do the following. Maybe I'll have 12 students. And then maybe I have some roster. Okay, hopefully that's 12. And you get the idea. So one thing I could do then is I could say, okay, well, I know that all my students are in 12th grade, so maybe I could do something like this. Students I, position I, each one is a new student, with a certain number of scores. Well, the name will be roster I, the grade will be 12, and the number of scores will be, say, 2. Or maybe I'll have that be a variable, something like this. And then that gives every single student a set of, so that gives every single student a name from my roster, a grade, and a number of assignments. Then I can start filling that. I could say, in here, maybe I'll have another for loop. And I could do this above, but I'm going to just do it here. You know what? Maybe I'll just do it above. I'll show you how I could do that. Students I dot add score, something like this. I could do this assignments number of times. So something like this, where I can add for each assignment. And every assignment I'll give them, say, a 50, because I'm a mean teacher. And so that would automatically populate every student with assignments. So how would I print this out? Well, I'd do the following. And I could again do this above, but I'm not going to. Maybe this will be toward the end. And then I'll say, I'll print out the information for each student. So let's try this. A, B, C, D, etc. So let's look up here. Student A is in grade 12, has scores 50 and 50, their average is 50. Student B, grade 12, 50, 50, average 50, etc. All the way through my last ones, which I populated for my roster. But you can see I could auto-populate all of your grades with 50s just like that. So I wouldn't be quite that mean. Maybe I'll do, let's say, 92, just to be frustrating. And then you see that's updated for every student. And then maybe I'll add a correction factor where every one would be plus I plus J. So maybe there's some variance here. So my earlier students get worse scores, my later students get better scores. So that's sort of a way to show that I'm not just populating each one, with the same thing. I could automate this and make it look sort of real. Maybe I set a baseline at an 85, and I run this, and you can see the top scores are in the 96s, the bottom scores are like the 85s. And so on and so forth. So there's a lot of utility in having a class that stores all this information, because all I have to do is set up a couple loops. I'm barely doing anything inside these loops, but I set up a couple loops and I get all this information that's varied and diverse, and sort of unique to each student almost. And all I have is this roster of names up here. I could, change it to Tim. You'd see the first one is Tim, and then maybe I'll change this one to Todd, just to show you that I am obsessed with male T names for some reason right now. Okay, and then Tara right there. And you can see that, oh, hey, Tara comes right before Todd. Um, and then maybe, yeah. So that's sort of a rundown of how I could extend this project to be really actually useful. And this shows the utility of having a class um, and then having an array of that object. So the class has an array, I have an array of that class, and I can access all that information very easily when I've defined how to do it in my student class. And that also shows the value of methods. So this covers basically everything we've learned, even stuff like um, double conversions or double and int conversions. So hopefully this is helpful.